Hi everybody. So I want to show you this diagnostic test for Precalculus that Mr. Rubenstein made. He actually made it as a final assignment for his students. But he's going to be altering it to just become a diagnostic test. It's freestanding, it doesn't have any deadline associated with it. And you can use it at any time over the summer, just to see where you are, see what your weak spots are and where you need to focus your study efforts. Okay, so I highly encourage you to use this, in fact, even multiple times. You can use it now just to see what kinds of questions you need to learn how to do. Many of them you'll have no idea how to do yet, but they're not difficult to learn. So you'll watch his videos, and then you can take the diagnostic test over and over. You'll just get different numbers for the same question types. Basically, the algorithm just generates problems of that type with randomly selected numbers, so that you don't have any recollection. You have to solve it by, applying a skill, rather than just remembering what the answer was that you already saw. So it's really good, and you can use it again multiple times. Certainly you should use it at least once toward the end of the summer, when you're completely done with your summer study, to check that you've acquired all the necessary skills, so that you'll be in the same place as everybody else going into calculus. Of course, you also have a lot more advanced knowledge about the foundations of mathematics, and about the rigorous versions of different things like trigonometry and so on that your classmates won't have. But you also want to acquire the kind of more basic knowledge. For example, how you write the equation of an ellipse. Things like that. Okay, so these are simple skills. They're easy to pick up, easy to learn. You should be able to teach them to yourselves with the help of Mr. Rubenstein's videos quite easily. But let me show you how you would access this diagnostic test. Okay, so the first thing you do is just go to deltamath.com. And you're going to create a new account. And you should do this even if you already have an account. Even if you've already created a DeltaMath account in some other math class. Create this new account because it's going to ask you for a particular registration code. And you need to use this very specific registration code that Mr. Rubenstein made particularly for this purpose. So use some other email address that you didn't use the first time you registered. So, okay, you're going to click on Create Account, and then click on Student. So you see it says Create Student Account, and you'll want to put in this teacher code. And I'll post the code for reference on the Google Classroom page. But it's 613279. Okay, and then you're going to select Section, and you can pick Stern. And then you put your name. And I'm just going to create a kind of dummy account under my son's name. I could do it under my own name, but I've already done that in testing all this out. Okay, then you'll want to just pick some email address that you haven't used before. So I happen to have an old one. Oops. Asks you to verify it. Okay, and then it asks you to enter a password. I'm going to use my son's full name for that. Tobias Joshua Stern. Okay, and so it gives you notice that your account has been created. Click on OK, and now you have to actually sign in. Sorry about the slow typing. This is on an iPad. A lot easier to do this on a computer. Okay, and when you log in, you see that you only see one thing on your screen. It's this final assignment Precalculus. Okay, so Mr. Rubenstein used this as an actual assignment this semester, which is why you see that it says late credit available, because his students are still able to submit this for late credit. But over the course of the next week or so, he will be removing that and just turning this into a kind of permanent diagnostic test with no deadline associated with it. So don't worry about that. Just click on the orange field, and you'll see that it expands into a list of 25 skills. Okay, I'm just going to show you how you would go about submitting answers. So let's click on this first one. All right, you see the skill is called Equation of an Ellipse in Standard Form. And it's just asking you to write down the equation of that ellipse from knowing its center and also knowing its semi-axes, sort of the lengths of the shortest diameter and the longest diameter. Okay, and the way this works is that it's going to be an equation of the following form. It's like x minus a constant, and that constant happens to be the x-coordinate of the center. So since the x-coordinate of the center is marked as -7, we have to do x minus -7. In other words, x plus 7. Okay, now I need to square that, and then divide that term by the square of the sort of horizontal semi-axis. That is the distance from the center to the ellipse in the purely horizontal direction. And if you look at the little squares on the grid, you see that it looks like it's two little boxes horizontally from the center point to the actual circumference of the ellipse. So you put that number, but you square that. 2 squared. Okay, now there has to be a term involving y as well, and it's very similar. It's going to be y minus the y-coordinate of the center, so y minus -2. Or y plus 2 squared, and then divide by the square of the vertical semi-axis. So that's the distance vertically, purely vertically, from the center to the circumference. And if we count boxes, it looks like 6 boxes. So we have to do 6 squared, or 36. And then we have to set the whole expression equal to 1. That's the way you write down the equation of an ellipse in standard form. Okay, so now if I submit that answer, it should be correct. But I want to just change something for the purposes of illustrating what happens when you submit a wrong answer. So let me just go and change this number here to 35 instead of 36, and I'll try to submit. Okay, so it first asks you if you're sure that you want to submit, so you have a chance to just see if you made a typo. Okay, I do intend to submit this answer, so I'll click yes. And you see that it tells you your answer is not correct, and you have 1 attempt remaining. Now what that means is that you have 1 more attempt at this problem with those particular numbers. If you fail another attempt, then it will give you the same problem again, but with different numbers. The rationale for that is simply that if you have too many attempts with the same numbers, you'll eventually just get it by guessing, because these questions tend to be written in a very particular way. They tend to be very contrived, simple situations where everything is a positive integer, and a small positive integer at that, usually between 0 and 10. The reason question writers do that is simply to make the calculations feasible. If they were to give you some completely random, values for the coordinates of the center or for the semi-axes, it would just be a mess to calculate. Okay, so but for that reason, if you have a lot of attempts, you're eventually just going to stumble on the right answer kind of by chance. Okay, so yes, let's acknowledge we have 1 attempt remaining. And I'm going to go into the answer field again and just, delete that. Okay, now this should be correct if I did everything right. Let's try it. Okay, and you see that it is indeed correct. It shows you the green check mark. Okay, so there you go. Now you can click Next Problem. Section complete. Move on. Okay. Okay, well, I guess it's giving me another problem of that same type. So let's just do it. Okay, again, we have the center is negative 3, 3. So I need to do x minus negative 3 squared. And then I have to count the boxes to determine the horizontal semi-axis. So that's the purely horizontal distance from the center to the circumference. Looks like 6, so then you have to square that. Then you'll have a very similar term involving y, but this will be y minus 3, because the y-coordinate of the center point is 3. And it looks like the vertical semi-axis is 3 as well, so we have to square that. And then set the whole thing equal to 1. Okay, so we got that right. Okay, I'm not really sure how many problems there are in each section. I guess that maybe there's just an unlimited number of questions in each section, and you can decide how many you want to do. But you can always just exit that question and go to the next one. Okay, so you see that here you're being asked for the equation of a parabola, which has a given focus at the point 1, negative 6, and then a given directrix, x equals 3. Okay, so you'll learn this in the videos, but the basic idea is that you can define a parabola abstractly as a set of points equidistant from a fixed focus and a fixed directrix. Directrix just being a line, focus being a point. So you pick a fixed point called the focus, you pick a fixed line called the directrix. They have to be non-incident with each other, meaning the focus cannot lie on the directrix. But given those data, you can then consider the set of all points equidistant from those two. And that is by definition a parabola. Okay, now you can see one point that's equidistant from the two is this point right here. Well, I guess you can't see me pointing to it on the screen. But if I just take the focus and move over 1 unit to the right, so that's the point 2, negative 6. That is obviously midway between the focus and the directrix. That point is going to be the vertex of the parabola. This is going to be a sideways parabola that opens to the left. And the vertex of it is going to be sort of the rightmost point on it. And that point is going to be 2, negative 6. Okay, but then how do you find the equation of the parabola itself? All right, well, it's not too difficult. Yeah, let me just get a piece of paper and we'll work it out together. There is a standard formula for this that you're going to learn when you watch Mr. Rubinstein's videos. But I want to show you that you can actually solve this problem without memorizing anything. Okay? So what I'm going to do is I'm just going to write down the distance from some arbitrary point, xy, to both the focus and the directrix. Okay? The distance from xy to the focus is going to be the square root of x minus 1 squared plus y minus negative 6, or y plus 6 squared. That's just from the distance formula. Okay? So, in other words, what I'm doing, I know you can't see me writing this down, but I'm just writing down the expression for the distance using the distance formula from an arbitrary point xy to this fixed point f, which is 1, negative 6. And the expression you get is, again, radical x minus 1 quantity squared plus y plus 6 quantity squared. Okay, then I have to set that equal to the distance from xy to the directrix. Okay. Now, how do you find the distance from a given point to a vertical line? All right, well, the distance is measured perpendicularly to that line. So the distance from the point to a line always is measured perpendicularly to that line. So if it's a vertical directrix, you have to measure the distance purely horizontally. So all that's relevant is the x-coordinate of the given point and the x-coordinates of the points on that line. Okay? The x-coordinate of the given point is simply x. And then on that line, every x-coordinate is equal to 3. So the distance is simply going to be x minus 3, but in absolute value, because distances are non-negative by nature. So yeah, that distance is going to be simply the absolute value of x minus 3. Now if you set those two expressions equal, you have a radical on one side, and you have an absolute value sign on the other side. And you can get rid of both of those very, very nicely by just squaring both sides. See, if you square both sides of that equation, on one side you're going to have x minus 1 squared plus y plus 6 squared. On the other side, you'll just have x minus 3 squared. You don't need to write the absolute value of x minus 3, quantity squared. Because once you're squaring things, the absolute value sign becomes redundant. Right? The absolute value sign would strip away a minus if the number is negative. But when you square something, it would kill that minus sign anyway. So yeah, because of the redundancy of the absolute value sign, you can just delete that. Okay, and now I have the following equation. X minus 1, quantity squared, plus y plus 6, quantity squared, equals x minus 3, quantity squared. And if you just multiply all of that out, you'll see that the x squared terms cancel, because there's an x squared term on one side, and there's also an x squared term on the other. All right, I'm going to work it out. It's x squared minus 2x plus 1. Then you'll have plus y squared plus 12y plus 36 equals x squared minus 6x plus 9. So again, the x squared terms cancel from both sides. And then you can basically just isolate essentially x and express x in terms of y. Okay, to isolate x, I'm going to add 2x to both sides. And that's going to give me a minus 4x on the right-hand side. But I also want to subtract 9 from both sides. And that's going to give me like y squared plus 12y plus 28 equals negative 4x. And you can write the equation of the parabola in any form that's convenient. So I'm going to write it this way. In fact, you can even write it in the form we originally got before we even multiplied anything out. Let's just try that and see if that works. The form that I got before I even multiplied anything out, just from the distance formula, was this. Okay, and you see it's correct. Now, in the solution, they're giving you a method for doing this that's a little different from the method that I just gave you. Basically, they're doing it by telling you to find the vertex, which is the point 2, negative 6, as we started out saying. It's that point marked in green there. Then they're telling you to find the p-value, and you'll see what that is when you watch the videos. And once you know those, you can easily draw the parabola. But anyway, there are various forms of the answer. When we simplified it, we got essentially the form listed under this column, form 1. Okay, but the forms are all equivalent anyway. So you see how this works. You can then go back I think you have to have gotten sort of maybe two right in each category to get a check mark for that category. But you can go through all of these. Okay, let's try one more. You're going to learn what the determinant is when you watch the videos, the determinant of a matrix. For a 2x2 matrix, it just means the product of the elements on the main diagonal, which goes down to the right, minus the product of the elements on the off diagonal, which goes down to the left. So I want to take the product -3 times -6, and then subtract away from that the product 6 times 4. Okay, so -3 times -6 is 18, positive 18, and then subtract from that 6 times 4, which is 24. So what is that? -6. Okay. So you'll do this at your own leisure. All right, guys. Good luck. Don't forget to watch Mr. Rubinstein's videos. I recommend watching 2 or 3 a day. You can split it up, or you can do it all in one block. But they're pretty short, so that should be very feasible. And I also would recommend just taking brief notes whatever seems important. The key formulas and so on. It's usually very helpful to write these things down, both to help you remember them better and also to have kind of a permanent record of them you can easily refer back to if you ever need to later next year. Okay, with that, it's been a real pleasure. Thank you so much. It was a wonderful experience. And please be in touch. I'm around all summer. I'll be answering my email. So if you have any questions or you just want to say hello, I would be delighted to hear from you. Take care, everybody. Be well.